Hello students, let us discuss an important concept in chemistry, that is a mole concept. Take an example of the reaction of hydrogen and oxygen to form water. Look at the reaction, hydrogen plus oxygen give rise to water. That means here two hydrogen molecule is reacting with one oxygen molecule give rise to two molecules of water. That means this above reaction can be indicated in two ways. How? First, the two molecules of hydrogen combines with one molecule of oxygen to give rise to two molecule of water. Why I am saying two molecule of hydrogen? Because 2H2. 2H2 means two molecule of hydrogen plus one molecule of oxygen. That is, here it is 1, therefore one molecule of oxygen give rise to two molecules of water. Why it is two molecule? Because 2H2O means two molecule of water. So how we indicate this reaction? In terms of molecule, that is two molecule of hydrogen combines with one molecule of oxygen to form two molecules of water. But we can also indicate this reaction in terms of mass. In terms of mass, how we indicate this reaction? 2H2. That means the mass of one hydrogen molecule is 2U, and when it is saying 2U, that means 2 into 2, that is equal to 4U. So what is the mass of 2H2? That is 4U. What is the mass of oxygen here? That is 16U. And what about the mass of water? The mass of water, because molecular mass for water is 18U. If I am saying 2H2O, that means 2 into 18, that is equal to 36U. So how we define this in terms of mass? That is 4U of hydrogen molecules combined with 32U of oxygen molecules to form 36U of water molecules. So in terms of mass, we have defined this equation, and in terms of molecules also we have defined this equation. That means the above reaction is explained in terms of either the mass or the number of molecule. But it is more convenient to refer the quantity of a substance in terms of number of its molecule rather than their mass. So in order to represent a substance in terms of a quantity of a number of molecule, a new concept was introduced, a new unit was introduced, that is a mole. What is a mole? The mole is the amount of the substance of a system contain 6.022 into 10 raised to power 23 number of specified elementary entities. And 1 mole of anything is equal to 6.022 into 10 raised to power 23 in numbers. Definitely, you will not be clear about this definition. So let us clear this definition by taking another example. Let us talk about dozen. What do you mean by dozen? Dozen represent a number here, that is 12. 1 dozen is equal to 12 number. So if I am saying that if I want a 1 dozen of egg, so what it means here, that is I want 12 number of eggs. So here the 12 number represent a dozen. What about if I asked 1 dozen bangles? What it means? 12 bangles. It means 12 bangles. So what is common in these? What is common in these? That is the number is common here. So 1 dozen egg means 12 egg. 1 dozen bangle means 12 bangle. So the number is common in this, that is the number 12. So instead of saying 12 eggs, what I can use the word here, 1 dozen egg. Instead of using the bangles, 12 bangles, I can use a word 1 dozen bangle. Similarly, when we talk about the pair, one pair of hand means 2 hands. One pair of rings means 2 rings. One pair of shoes means 2 shoes. So what this pair means? This pair means a number 2. So a pair of anything that is equal to the 2 number of that substance. Similarly, a dozen of anything represented the 12 number of that substance. So similarly, the mole concept also says that a substance which have containing a fixed number here, that is 6.022 into 10 raised to power 23 number. So 1 mole of anything is equal to this number. Just like 1 dozen of anything is equal to the 12 number of that substance. Similarly, 1 mole of anything is equal to this number of that substance, that is 6.022 into 10 raised to power 23 number. You can see it's a very huge number, so it is not comfortable to write in this way. So how we write this one? That is 6.022 into 10 raised to power 23 numbers. So what we can say that a mole of any substance is equal to this much number. So these, if I talk about the mole of atom, that means 6.022 into 10 raised to power 23 number of atoms. That can be explained with the help of like if I'm talking about 1 mole of water molecule. So what it means, that is equal to 6.022 into 10 raised to power 23 water molecules. Just like I told you, 1 dozen egg means 12 number of egg. Here 1 mole of water molecule is equal to this number of water molecule. But if I am talking about a oxygen molecule, therefore 1 mole of oxygen molecules means what? This much number of oxygen molecule. What about 1 mole of oxygen atom? Then in that case, this much number of oxygen atom. So what we can say that in all these, what is common here? The number is common. So what we can conclude from this one, that means 1 mole of any substance, it can be a molecule, it can be a atom, it can be an ion, whatever. So 1 molecule of any substance, that is equal to this much number of that substance. So when you read out this definition once again, it is clear that the mole of the amount of any substance contain this much number of elementary entities. These entities I told you, it can be an atom, it can be a molecule, it can be an ion, or even it can be an electron, whatever. So 1 mole of an atom means that is this much number of atoms. 1 mole of molecules means this much number of molecule. 1 mole of electron means this much number of electrons. Since this number 6.022 into 10 raised to power 23 number is not easily written in this way, because when you're writing in this way, it always happens that you will miss out any 1 0. So in order to make more convenient, we'll be writing this value in the term 6.02 into 10 raised to power 23. We are writing in this way. So here the entities or the particles can be an atom, can be a molecule, can be an ion, can be an electron. So can we say 1 mole of a bangle? Yes, we can use the word 1 mole of a bangle there, but it is equal to 6.022 into 10 raised to power 23 number of bangles. This number is given by a scientist called as Avogadro. So this value is called as a Avogadro constant. This constant value is named as Avogadro number, that is 6.02 into 10 raised to the 23 is the Avogadro number, which is a constant value given based on the name of the scientist Avogadro. So from this what we can conclude that if I am saying 1 dozen cookies, that means 12 cookies. But if I am saying 1 mole of cookies, that means 6.022 into 10 raised to the power 23 cookies. If I am saying 1 dozen car, that means 12 cars. But if I am using a word 1 mole of car, at the time it will be 6.02 into 10 raised to the power 23 cars. If I am using a word 1 dozen of aluminium atoms, that is equal to 12 aluminium atoms. But if I am using a word 1 mole of aluminium atom, that is equal to 6.022 into 10 raised to the power 23 atoms. So maybe the question arises here, can we use a word mole for other quantities like cookies, cars, etc.? Yes, you can use the word mole for giving a number to cookies, cars or anything. But the thing is that it is a huge number. So practically we will not be coming with this number. So it is more, this number is most preferred in the case of chemistry, where we are dealing with a small atom, small molecule. So definitely their number will be very large or very huge. In that case, we are using the concept of mole. So the mole concept always represent a amount of the substance, that is number of particles present in that substance, which is equal to 6.022 into 10 raised to the power 23 numbers of that particles. But note it here, the number is same, that is 6.022 into 10 raised to the power 23 in all these cases. But the mass is not same. You can see the mass of 1 dozen cookies is not equal to the mass of 12 car, that is not equal to the mass of 12 aluminium atom. So that means the mass is not same, but the number is same. Let us do one thing. Find out the mass of 1 dozen elephant. 1 dozen elephant means 12 elephant. Mass of 1 dozen book, that means 12 books. And the mass of 1 dozen pen, that is 12 pen. Take out the mass and find it out whether you will find an equal mass here. Definitely not. The mass of each will be different. So we can say that these are common in only in number, but not in mass. That means they are common in number, but they are different in their mass. So in the case of a mole also, when we consider the 1 mole of a gold, 1 mole of a silver, 1 mole of a copper, when you find out the mass of 1 mole of gold, 1 mole of silver, 1 mole of copper, you find that they will be having different mass. That means these all are same in numbers, that is 6.022 into 10 raised to the power 23 numbers. These are same in numbers, but they are not same in mass. So in order to find out the mass of a mole, we'll be using a term here, that is molar mass. What is molar mass? The mass of 1 mole of any substance in grams is called as molar mass. So already we have discussed about some mass, that is molecular mass, atomic mass. So let us compare what is this molar mass with other masses. The atomic mass of an element gives us the mass of 1 atom of that element that is represented in terms of atomic mass unit U. That is important. Atomic mass is the mass of one atom of that element, and the unit which we are using to represent atomic mass is U, that is atomic mass unit. And the mass of 1 mole of that atom, that is important. Here it is 1 atom and here it is 1 mole of atom. So you can find the difference here. 1 atom means, if I am talking about hydrogen atom, that means if 1 atom means 1 H. But if I am saying 1 mole of hydrogen atoms means 6.022 into 10 raised to the 23 number of hydrogen atom. That is different here. 1 atom, this is 1 atom, this is 1 mole of atom. So the mass of 1 mole of that atom is called as molar mass of that atom, and it is represented in terms of grams. Therefore we called it as a gram atomic mass. Look at the difference here. Atomic mass of hydrogen atom, that is 1 U, that we have already discussed. Atomic mass of hydrogen is 1 U, but the gram atomic mass of hydrogen is 1 gram. So in order to represent a atomic mass, we will be using a unit U, but in order to represent a gram atomic mass, we are using a unit gram. You can check here. For hydrogen atom, the numerical value for atomic mass and gram atomic mass is same, that is 1. But what is different here? Their units are different. So what 1 U represent? 1 U is the mass of 1 hydrogen atom, but 1 gram is the mass of 6.022 into 10 raised to power 23 number of hydrogen atoms. So there is a difference here. Let us take an example for oxygen. In the case of oxygen atom, you can find out the atomic mass of oxygen is 16 U. The gram atomic mass for oxygen atom is 16 gram. Check here. The numerical value is same, but unit is different. So for any atom, the atomic mass, if it is XU, therefore the gram atomic mass will be X gram. So it is very easy to write the gram atomic mass. Once you have learned the atomic mass, that is a particular value with the unit U. So what will be the gram atomic mass? The same value, but the keep unit gram in that case. Now let us talk about the case of molecules. What is molecular mass, which we have learned? Molecular mass of a molecule gives the mass of one molecule. What is molecular mass? It gives the mass of one molecule. It is represented in terms of atomic mass unit. So what will be the gram molecular mass? That is, the mass of 1 mole of molecule is called as molar mass of that molecule. So it is represented in terms of gram molecular mass. Just now we have discussed gram atomic mass, but there we are concerned with atom. Here we are concerned with molecule. So we are using the term gram molecular mass. So what is molecular mass? Molecular mass is the mass of one molecule. But gram molecular mass is the mass of 1 mole of that molecule. That means 6.022 into 10 raised to the 23 number of molecules. Mass is gram molecular mass. So let us take an example of water molecule. As we have already discussed the molecular mass for the water molecule, that is 18U. So what will be the gram molecular mass for this water? That is also the value, the number is same here, that is 18. But what is different? In the place of U, you have to keep gram. So I think it is clear that what is molecular mass and what is gram molecular mass. Always it is easy once you have learned the atomic mass or the molecular mass. But when you are writing the gram atomic mass or the gram molecular mass, you have to change the unit. It will give rise to the gram atomic mass or the gram molecular mass. So let us compare this with a chart. Like 1 mole of a carbon atoms. That means 1 mole of carbon atoms. How we discuss this in terms of mass? What will be the mass? That is equal to 12 gram of carbon atoms. What do you mean by 1 mole of carbon atom? The mass of 1 mole of carbon atom is equal to its gram atomic mass. That is 12 gram of carbon atom. But when we talk about the number of particles, I told you number of particle is same for 1 mole of any substance. So if I'm telling 1 mole of a carbon atoms means what? That is equal to 6.022 into 10 raised to power 23 number of carbon atom. But if I'm asking for you, what is the number of molecule in 1 mole? That is equal to 6.022 into 10 raised to power 23 number of molecules. And their mass will be equal to the molecular mass in grams. So we can compare here the mole in terms of mass also, the mole in terms of numbers. As I told you, the numbers always same. 1 mole of any substance is equal to the number 6.022 into 10 raised to power 23 numbers. But the mass is different. So in your textbook, you can have this chart. Just go through this chart. In this, you can easily compare the number of particles and the mass for each which is discussed here. Now, let us differentiate between molar mass and molecular mass in the tabular form. First, we can define molar mass. Molar mass is defined as the mass of a mole of a substance, but molecular mass is referred to the mass of the molecule. That means it is the mass of 1 mole. It is the mass of 1 molecule. It is measured in gram and it is measured in the unit, that is atomic mass unit. So from this it is clear that what is the difference between molar mass and molecular mass. So let us conclude this concept of mole. That is, the symbol for mole which is used is MOL. What is the symbol for mole? That is MOL, and it is a unit for the measurement of amount of substance in the International System of Unit. So in SI unit, the amount of substance is represented in terms of mole. The symbol for mole is MOL. So in this it is clear that a mole of any particle is equal to 6.022 into 10 raised to power 23 number of particles. Here the particles can be atoms, molecules, ions, electrons or any other. So this is all about the important concept which we had discussed about the mole. So the problems related to the mole will be discussed in the next videos. Have a nice day.